Hello, my name is Mario Martinez and welcome to this tutorial on ABB Robot Studio. In today's tutorial, we're going to be looking at how to make digital inputs and digital outputs, how to use them, and how to program them, how to configure them using the controller path in ABB Robot Studio. To this end, we're going to select first the robot. From the ABB library, we're going to select the IRB120. We're going to select OK. And also, we're going to import as well the virtual controller from layout. In here, we can put a name if you want. We go to Next, RobotWare 6.16, then we click Next. And in here, we can configure if we want some options of this. Some options of this robot, of this controller. Inside the options of the controller, we can see that, well, as we saw before, we can change the language. This is for the flex pendant or the jig pendant. We also can simulate some industrial networks, some adapters, etc., etc. We have a lot of options in here that this software Robot Studio provides. In this case, we're going to simulate something just for the sake of using it. Let's simulate an industrial network. Yeah, we can use a Profinet network controller device. This one. You see it started in here into the system options. We can change the language if we want to Spanish or something. But in here, we're going to leave it in English, and we're going to add an industrial network controller or device in there. Of course, we don't have to do this. Actually, we can do it without this. But this is just to simulate this. Let's say, like, for example, the inputs to this robot, they come in this network, is Profinet, and it comes from another device in the network. So we're just going to simulate that. We'll press OK, and we finish. By the way, if you don't add this, do not worry. You can still make this tutorial without adding this Profinet network module. So I just click Finish here, and then my controller is going to start. There you go. My controller has started. You can see it in here. Now I'm ready to start building my setup. In this case, the first thing that we're going to be doing is I'm going to add a small table. So import library. From the training objects, I can add a small table. Yeah, just clicking here. As you can see, the table is going to appear there. Now I'm going to change the position of the table. So now I'm going to change this position. I can just go to Modify, Set Position. You can see here I can put it in the world reference frame. I think I'm going to put it just in the middle. You know, the table in the middle. I can actually measure the table if you want. You can here you have some measurement things in here. Here you can see that point to point, measure the distance between 2 points, and I can measure, if I select, of course, the snapping object, I can measure from that point to that point. You can see 750. Yeah, so I want to put it maybe in the middle of this. Yeah, I can put it in the middle. I can actually make the table smaller, which I think that's the first thing I'm going to be doing, because as you can see, it's quite large. The table is quite large, and the robot is not that big. So I'm going to make it smaller. So the first thing that I'm going to do is I'm going to select my table. Here I go to the Modify tab up here, and inside the Modify tab, I can scale it. Here it is, Scale. Let's put a scaling factor of 0.8 so that I can make it smaller. As you can see now, my table is small. Yeah, now I can remeasure it so that I can center my table. So now I'm going to remeasure this from that point to this point. I'm sorry, no, this point in the table to that point in the table. And as you can see, the distance is 600. So now I know how much if I want to center it, I know how much I have to do it. So I can just, I can close this, select my table again, Modify, Set Position. And now I can put it at, you see in the y-axis, I want my table to be like in the front, like in this section. So in the y-axis, I'm going to select like -300 to keep it centered. and maybe, I don't know, 250, in the X direction so that it's in front of my robot. I'm going to apply, and there you go. I can close this, and now my table is at a nice position from my robot. Okay, also I need to add a tool for this for this tutorial. We're going to add one of the training object tools, that my tool, that one. You see it appear underneath the robot, but don't worry. Remember, we're just gonna drag and drop it into our robot so that we can have our tool ready to use. Another really interesting thing that we can do now that we have our robot and our table there, we can verify our working envelope. So if we right click on the robot here, we can go all the way down to show work envelope, and we can see this is the robot and the wrist and the envelope of the wrist, not of the end effector or the active tool. And you can see that those are the position, that's the workspace of my robot. You can put it actually in 3D if you want to see it in 3D. You can actually put it like this, and you can see the working envelope of this robot. Yeah. Also, you can do it with the active tool, so the working envelope is going to grow because what is good, the working envelope of this point. So it's going to extrapolate the working envelope, and now you can see that my end effector can work in this region. You can see there is a small region in the table that you cannot do anything in there, but the rest of the table is you can work in there, so it's fine. So you can see the working envelope of my tool. I'm just going to remove everything, and I'm going to close this. This is just for you to see if my table is inside my working region. Yeah, of course, one of the, what I should have done is to move the table a little bit in the X direction so that the whole table is inside my working region. But for now, I'm just going to leave it like that because it's just a simple example. So the next thing that I'm going to be doing is I'm going to import some geometry for this task. In this case, I'm going to browse the geometry, and I'm going to import the PCR fixture blue and PCR fixture assembly red. So these two, I'm going to import them, both of them. Open. There you go. And you will see what I'm gonna be doing. I'm gonna put the robot in invisible. I'm gonna make it invisible. So as you can see, it's a, in biological sciences, one of the things that they have to do sometimes is to change certain proteins or certain chemicals or certain whatever between this small, they are called PCR fixtures. So basically you have a lot of small bottles in there, or small vials, and you want to basically, if you have some proteins or some chemicals in here, you want to transfer them between one well, we call them wells, yeah, between one of these vials to another. Yeah. So you can see this is a PCR plate. So what we're going to be doing is, as you can see, I have two PCR plates. So basically I'm going to use a very massive robot just to change, and this is for the sake of an example, of course, just to change some chemicals that, we're going to try to simulate that there is a chemical here, and we want to transfer it to another well or into another PCR plate. So I have two of them. I have a red and a blue. You cannot see the red one because it's underneath the blue one, but do not worry, you will see it. So the first thing that I'm going to be doing is I'm going to select this. I'm going to select this, and the first thing is I'm going to move it. Yeah, so modify set position. I'm going to move it to the top of the table. In this case here, I'm going to select the red square, select the point at the middle of the table, and you can see now that it's in that position. Of course, I don't want it exactly in there, so I'm going to move it. Let's say I think 5 is more than enough. Just 5 millimeters to the left. Apply. And now you can see the other PCR. Here's the other PCR plate. So I'm going to set the position in here. I'm going to make it the same, the center of the table. Apply. So you can see it's in this almost the same position. But in here, I think I'm going to put, it was 95, minus 95. So that you can have one beside the other. Yeah, as you can see. Let me see if I modify this a bit more, just for the sake of it. Or I can just leave it in there. It's fine. I think it's fine. Or I think it's because they are quite big. So I'm going to put it minus 100 or minus 105 or something like that, just to keep them separated a bit. But it's fine. You can see there. There you go. Now I can close this. And there you go. Now I have both of my PCR plates. So basically now I'm going to be using my robot. So this is what we're going to do in this tutorial. I'm going to be using my robot to move, I don't know, from this vial, from this well, we call them wells. So from this well or this vial to this PCR vial in there, and the next one to the next one, the next one to the next, so on and so forth. I'm going to be changing. I'm going to be making those movements in a repetitive movements. So now we have our controller. It's fine. The controller is there. I can actually now move my robot. I can jog the TCP if I want to. So I can move my robot. It's perfectly fine. Everything is working. I can save my project. And now I can start making the positions that I need. Yeah, I can start making the positions or making the targets that I need to do this operation. Now, the first thing that I'm going to be doing is to create a work object. So what is a work object? As we said before, we can create a work object is the reference to all my targets that I'm going to be putting, one of the references. So first, I'm going to create here a work object. I can put it WO. I always like to keep the first two letters capital so that I know what I'm referring to. Then I can here put a table underscore fixture, something like that. And in here, I can select the position of the user frame. Now, when I have things like this, I'm going to teach you another way of setting up, instead of just putting the position in X, Y, Z direction. Actually, in here you can just put in here the position of the corner of the table, like that one. It's going to be fine. But instead of doing that, we can do it also by points, frame by point. So for example, now you can select either in here frame by points. You here you click on the drop down menu and it's going to appear this small square where you can get the position. Basically the position you get is the position in XYZ, and then you put, because this is the point, this is the position of a single point, and then this is the position of the x-axis. So you basically have to put a point in the x-axis and a point in any place on the XY plane. And with this information, it's going to make the reference frame in here. Like, for example, this is the position of the point that I want to do, like, for example, here. And this is the position on the x-axis. I want my x-axis to be this way or maybe that way, wherever, whichever way, or maybe down. If I want it down, why not? But maybe I want the x direction to be here. And the XY plane position, because remember, this is a line. The plane can be diagonal or whatever. So I can select another point, any point on the plane, like for example in the table, that one. And if I press accept, it's going to create here the frame of reference between that point, this point, and that point. And it's going to create the frame of reference there. And the x direction is going to be this point because I selected this as my x direction. This can be one, or I can use the 3 point, which I think is, I like it better. So the 3 point is basically you select the first point on the x-axis. Like for example, I can select this point on the x-axis. Just select here, and then this point, and then another point on the x-axis. Now this one here, for example. So this is going to be my x-axis. And then it tells you like, okay, give me a point on the y-axis. and I can give it like I click in there and give that point as my y-axis. And when I click accept, it's going to create between the intersection is going to create the xy plane, and from there is going to derive the rest of the planes. So I can just click accept in here, and there you go. Now the object frame, the same thing. I can do frame by points. Remember the user frame, usually the tables or usually where the things are going to be located at, and then the object frame is where we're going to be working in. Usually, for example, what they do is they put a fixture in here that keeps this in place. But for now, let's imagine that these two trays are always in place. The only thing that changes are the PCR plates, so they can be removed. But these two white things or these two fixtures are always in the same place. So what I'm going to be doing is I'm going to declare here a position or an object frame in the area that I'm going to be working at. In this case, I'm going to create here using the 3-point. I can either create it here at the base, which I think that's the best. You can just create at the base, and if you change the fixture of position, that's it. If the table remains in the same position and you just change the fixtures, you can just change the object frame. If you change the whole table, you can just change the user frame. But in this case, I'm gonna be using like here, just for this is just an example. So I'm just gonna create a reference frame more or less in here. Like you know what? I'm gonna create it at the top. Why not? Just so that you can see it clearer. But remember, you can create it wherever you want or wherever you feel is more important. Which actually I will create it in, in a normal design. I will have created it in the corner of this. But for now, I'm gonna create it in the top corner, just for you to see. So to create this in the top corner, I can select the 3 points. So I will select 1 point in the X direction. You see you have a rounding in here, a rounding edge. But I'm going to select the top of the rounding, this one. My second point in the same line. Let's select, we can select that one. And then I'll point in the y-axis. I can select a point in the y-axis. I select here. Point in the y-axis. And I'm going to select on top of the round. You see, on top of the round, there you go. I click accept, and then I click create, and you can see that it created an object frame in there and a user frame in here in the corner of the table. So now, in case I move these fixtures, I just move the object frame. In case I move the table, I move the user frame, and that makes it easier when we implement this in real life. So now I'm going to create the first targets. So for example, I can just select the tool target, and the first target that I'm going to create is at the center of this well. So like around there, here. Always make sure that you have selected the work object as the work table fixture, the one we just did. I create one in there. I will create another one just in the same position, but this one I'm gonna this is with respect to the world. I'm just gonna make it a little bit lower, yeah, so that you can, because one thing will be like, okay, having it, the tool coming in here, and the other one will be actually putting the tool down, so that it can kind of simulates simulates the taking something from this vial. So instead of I can move it in the Z direction here. Yeah, maybe I can put instead of 346, maybe 320, let's say. It's this one. Or maybe 300. Well, 300 was too much, so I'm just gonna put 350 maybe. Okay, modify, and then I'm gonna click on create. There you go. Now I have 1 point inside, 1 point in the top, and just I'm gonna create another one. I'm going to create another one here. Yeah, like in there, like I'm just going to create it in the same position. I forget to click. Okay, there you go. I just click it. And I'm going to create it instead of 359, let's put it 370. So 370, modify, and create. And there you go. Now I have 3 points. This point I'm going to call it to approach. Then this point is on the top, and this point is the inner point or the inner target inside this file. I can change the name, like for example, target top, blue, target inner, blue, and target, I'm going to call it approach. So this is an approach position of the blue vial. So now I have my 3 positions. I'm going to do the same thing with the other ones. Yeah, I'm going to create more points. I'm going to create 3 in here as well. Like, okay, 1, 2, 3 in the same position. Now for number 2, the only thing that I'm going to be doing is I'm going to put 370 into this one, modify. This one is going to be 350. And then modify, and then create the 3 points. And as you can see, I have the exact same 3 points now in this area. I can close this. I already created my targets. I can rename my target. Target top. This is the top. Yeah, top red. This one target approach red. And finally target inner red. Also, what I like to do as well is to create some sort of centered position, like around this section, so that, okay, whenever I finish this, I go to that position, then I go to this one, go do the same thing, go back and do the same thing. It's like a security position in the center, because if we go from this to that, you know, if there is something here in the middle or something happens, you know, it's difficult to get. So I always tend to make some security positions. So in this case, I'm going to make one like around here. I'm going to create another target, and I'm going to create it around this position. So to create this target, what I'm going to be using is the center of the table. I can just create it there, as you can see, but I'm going to modify, instead of being at, you know, at the bottom of the table, let's put it around here on this position. Let's put 470. Let's hope that works. If I modify, yeah, that's good. So we have a position there that is outside of the working area. Of course, I will put it a bit to the right maybe. But anyway, but this is just an example, so I'm just going to leave it there. I'm just going to create it. Yeah. And this, I'm going to call it, I'm going to close this, and this target T init position. Okay, now I have my init position. I have the other 3 positions. And in the work object 0 here, I haven't created anything, but I'm going to create this as the home position because I want to leave it as the home position, that one. It's fine, I think. So I'm just going to change here the work object for work object 0. And what I'm going to do is a teach target. Yes, I know that is in the work object 0. And now I have a target there, which is, I'm going to change it, target home pose. There you go, that's the home position. Yeah. Now, one of the things that we need to realize is that this, the targets that I just created, like this one and those 3 and those 3 as well, they are not quite in a good orientation. Because, for example, for the robot to reach this, like for example, let's go to the init position. I can just right click on it, and I can view robot at target, or view the tool at the target. let's put the robot at the target, and you can see it cannot be done. The robot doesn't move, should move automatically to that point, but it doesn't, because there is no movement. There is no movement that allows me to reach this, to reach this point with this robot. So I need to change my orientation, because what do I want? Remember, the orientation of the end and the end tool is this one: set downwards, y to the right, and x to the back. So that's the orientation. So I need to make the same orientation here so that my tool arrives to this point. So to do that, I'm going to change the orientation. I can just modify position or modify target, and then rotate. And I'm going to rotate, I think it's 180 degrees. I'm sorry, not this one. 180 degrees in the Y direction. In the Y direction, if I apply it, there you go. Now set is downwards. It's like this. I can close it. And now if I view my robot at this target, now it reaches the target with that orientation. Yeah. I need to do the same thing for the rest of them, for the rest of the target. So what I'm going to be doing is just copy position, copy orientation relative to the world, and I'm going to select which targets, basically all of them. I want all my targets to have the same orientation. Click, apply position relative to the world. There you go. And now all of them are oriented properly. Now if I change it, my robot can reach all of them, like the approach. For example, the approach blue, there you go. The top blue, there you go. And the inner blue, I'm sorry, inner blue is, where is it? In inner blue, there you go. So I just did all my targets. The next thing that we're going to be doing is the paths. We're going to generate two paths. In this case, I'm going to here put empty path. I'm going to rename this path to I don't know, blue plague path. Yeah, or maybe I can just put in here in capital letters path blue plague. I think that's better. We're going to generate another one, rename it as well, path red plague. There you go. And I'm going to start adding the different targets that I need for each one of the plates. Now the first thing is, of course, I'm gonna move to the initial position. This is always a must for both of them. So I'm gonna add the initial position, init pose, to the blue plague. There you go. Initial position. Then when I'm in the initial position, the first thing that I'm gonna be doing is I'm gonna go to the top. Well, not to the top, I'm sorry, to the approach blue. This is the second point. Then top blue, and finally inner blue. Yeah. Then I have to repeat again, because now I'm inside. Now I want to go outside. So I have to repeat top blue, approach blue, and then init pose. So as you can see, the first one is initial position, approach, top, inner, top again, approach, and initial position. There you go. I can change the type of movement. Instead of L, I can put some J movements if I want to, but in this case, I'm just going to leave it in L because it's just a simple example. Yeah, just linear movements, because they are quite simple movements and it doesn't matter. The same thing I will do with the right plague. I have to go first to the initial position. Yeah, I'm gonna the initial position in the red, then top red. I'm sorry, top red. Approach red, top red, inner red, and then again top red, and approach red, and then go back to the initial position. Okay, so now I have the same. I can repeat it again just to double check. Approach, top, inner, top, approach, init. I can then synchronize these paths and these targets. I can synchronize them to rapid, to the controller. I synchronize everything. And if I go to rapid, you'll see that it's already here inside my main. Here you go. You have all the targets in there, and you have the path red plague, path blue plague, and you have the two of them here. Yeah. Now, in rapid, what I can do is I can modify the velocities and the in this case the zone or the area around the point. If we remember correctly, if we put this set equals to 100 or set 100 in rapid or in when we do our target, when we do our path, we remember that this set 100 means that around this point there is going to be like a circle, a 3D sphere that is going to be 100 millimeters in diameter. I'm sorry, in radius, a radius of 100 millimeters, and basically this is the tolerance to approach the point. So it's 100 millimeters away. So basically, what I'm telling when I'm making the function, when I'm making the path, I'm telling my path generator, like, okay, you have a tolerance of 100 millimeters. So it doesn't matter if you don't touch the point, as long as you are not 100 millimeters away from that point. So now I'm giving the path generator more flexibility. For this case, for example, for the approaching point, I might not care too much about the set or the zone, the radius around the point. But for the two of them, for the top one and for the inner one, I do care. I want that movement to be slow and to be a fine movement, because if you go too fast, you might break something, or you have to be very careful. Yeah. So to do that, we are going to go to rapid, and we're going to change the values of these of the velocities in each one of the points, or in each one of the movements, and we're going to change the radius around the point, or the zone around the point. So now in our rapid file, we're going to change these values. Like for example, I like to decrease the speed. Like for example, here I'm going to increase the speed to 400, and I think I can leave it as 100 for the zone, for this initial position, for this init position. For the approach, when I am approaching, I'm also gonna decrease the speed maybe to 200, and I want this to be like, I want to rely more on this position, so it's gonna be 50. Then the top, this one, now I'm gonna decrease even more the speed, maybe 100. Actually, for the inner as well, 100, and going back to the blue also 100. But in this case, I don't want set equals to 100. I want it to be a fine. Yeah, basically to reach the point. Fine, fine, and fine. I don't want you to play around. And then again, with the approach, I might decrease it also to 200. Yeah, to 200, and to my init, I will do 400 now, because it's a far away point, so 400 there. And in here, I might go back to set equals to 50. And for the initial position, I can leave it at 100, so it's fine. The same thing, I'm gonna do the same thing in here. I can just copy paste this. Because those are basically the exact same points, just in the other direction, just for the red one. There you go with fine, fine, fine. And then in here is 250. Here set equals 50. And this one is 400. And set equals 100. So it's fine. So I think that's it. I can just double check. I can just actually check the program here. There is a check the program there. I can apply everything, apply all. Yeah, and I can synchronize to the station, synchronize everything back to the station, that because I just changed everything. So now in my station, I should have all these already changed. Actually, I can check in here. Like for example, for init pose, I can just edit instructions, and you can see it's 400, 100, so it's already changed. And for the inner, modify edit instructions 100, fine, so it's fine. So now everything is changing here, and I can actually, check, like for example, move along the path. There you go. So you can see it's moving along that path, and then move along the other path if we want. Because I move into the red one, but I can also move into the blue path. Move along the path. And there you go. So I have two paths already done. I can define an entry point if I want. Like for example, this one, I can just make it set simulation entry point. Yeah. And I can, when I do the simulation, if I press play, it's going to do this process. Yeah, it hasn't done the other one because I haven't set it. Yeah, but I'm gonna make sure that you do one and that you do the next one. So to do that, let's go to the rapid here. And now in this case, my entry point in this case is the blue plaque. So it's gonna do only this process. But in here, what I want, I'm gonna use the main, and I'm gonna call both processes in the main section. And I'm gonna call my main is gonna be now my entry point. Yeah, so I can literally just Control C, Control V there, Control C, Control V there, semicolon like that. So basically now I put both of my functions inside my main function, and I'm just gonna put some semicolons in here. Yeah, and okay, blue plaque, red plaque, and that's it. We have the two subfunctions. Now what I'm gonna do is I'm gonna apply all. Don't forget to apply all. Then I'm gonna synchronize to the station, because this is already done. This is already in the controller. I'm gonna synchronize this to the station. I'm gonna synchronize everything. And then I'm gonna go back to home. And in here in home, you have a main function here. I'm gonna set my main function as a simulation entry point. There you go. And I can just start my simulation, just play. You will see that it's gonna be 1 and 2, and that's it. It's gonna do it 2 times. Now, one of the things that we can start doing here in the main is we can, like, first of all, we want this to be repeatable. So we can say like, okay, while true do. So basically it says while, you have the condition of the while. In this case, it's a true, always a true. So this is going to be always running. I'm going to just, this is not Python, so it doesn't matter if you don't put the tabulation, but I do like to keep it clean. That's why I'm going to add the tabulation. And in here, I'm going to put the end while function. If I do this and then apply all, and then synchronize to the station so that I can synchronize all the modifications that I did, I can go to my simulation now because I haven't changed anything, and I can press play. And you can see now that my robot is going to keep continually doing this. It's going to call one function and then the other, one function, then the other, one function, then the other, because I did a while loop. I can just stop my simulation now. Yeah, and I can go back to my code. Yeah, and in here now, you can see that I'm starting to build a larger and larger and larger program. And this is how it should be. Actually, you program the points using the using the, like in real life, you program the points using the simulation, or in real life you're using the robot, you teach the points of the that you're going to be using with the robot, and then inside the Rapid is where you do the rest of the things. You start programming all the functions and everything, where you want the robot to move, how many times, etc., etc. So this is what we're going to be doing actually in the next in this tutorial. So another thing that I'm going to do before start programming more, I'm going to create another path. Yeah, I'm going to create another simple path just to move uh, from wherever I am, just to move it to home. Yeah, I'm just going to create another path. And this one, I'm going to call it path home. And in here, I'm going to add the home position. There you go. In the home position, I can modify it. I can modify it in here. Modify instruction the speed, maybe like 400. And the modify instruction the zone, we can leave it at 100. It's fine, just for the sake of this example. And there you go. I'm going to synchronize this to Rapid. Synchronize everything, and there you go. Yeah, did I synchronize? Yes, I synchronize everything. So now, in Rapid, I have all my positions, all my targets. Yeah, and you can see that now I have another one that is called path home. Yeah, so I can create more paths if I want to. Now, I can create paths from here instead of creating them from the simulation per se, or from the station. I can create them in here as well. But before doing that, I'm going to create something that is basically, you can see here that these positions are like set positions, like I cannot change them. Yeah, but in reality, in my experiment, what I want is to, okay, this whatever is in this vial goes to that vial, whatever is in the second vial goes to the second vial, so on and so forth. So that's what I want to do. So to do that, basically what I want to make is an offset. It's an offset of this position. This is my position. I just want to offset it. So I'm going to create an offset function. I'm going to make this this target, well, these paths, I'm going to make them with an offset so that they can start varying, start changing each time we do an iteration. So to move from one well to another well, or from one vial to another vial, what we have to do is we have to use a function that is called offset. And why is that? Because if you see here, yeah, if you see here the distance, the offset from this distance in x and in y, and x and y, for example, from this one, the offset in x is the same as the offset in here in x. So basically, if I have the position here, I just need to put an offset and it will reach this position. If I have this position here, I just put an offset and it reaches position. And the same thing, I have to add the offset until I fulfill this whole row. Yeah, and I'm sorry, this whole column. And then I put an offset to go to the next row and fulfill it. Then I put an offset and to go. And the same thing for this one. It's exactly the same amount of offset for both of them. So if I can just calculate the amount of offset, I can just add it to the target and it will go one by one. To do that, we're going to go to Rapid. And in here, yeah, like which are the, first of all, we have to ask ourselves, which are the positions that require an offset. And in this case, the initial positions, they do not require offset. The only positions that require an offset are the approach, the top, and the inner, because those are the ones in the vial. Yeah, so I want my robot to go here, then go back to the init position, and then go back here. So I can do that just by checking in here, just by adding in here OFF, S, like offset, offs, I open a parenthesis, and just before the first comma, I close the parenthesis. And this is saying like, okay, move L, use this movement, offset this target, offset it. And then by how much? X, Y, and Z. So in this case, I'm going to put dx, comma, dy, and in Z. I don't want offset in Z, just in X and in Y. So I just want to offset in that position. So now where does this dx and dy come from? Where I'm going to add it in as a parameter to my function. So I'm going to create here a parameter, a numerical parameter that is dx, and another numerical parameter that is dy. Yeah, and I'm going to copy paste this offset to just like this. I'm just copy pasting because I don't want to type a lot, because it's the exact same offset for, I'm sorry, not for the final init position. We said that we don't want an offset in here. And we can just, I think I erased. Yeah, I erased one of them. All right, I'll do it again. I just copy paste the offset, 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 offset. I'm sorry, not in the last one. And then dx, dy, and 0. Here, dx, dy, and 0. Dx, dy, and 0. Dx, dy, and 0. And there you go. Now what I'm doing is, if I know the distance, the offset distance is going to move this to the offsetted distance. I'm going to do exactly the same because now we know that it's the same offset in both of them. So I can just copy paste the offset part in here into the red plaque. Offset, 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 and offset. And then by how much? Dx, dy, in 0, because it's the same amount of offset. I'm sorry, again, here I made a mistake, not for the initial position. I don't want an offset for my initial position. I just want an offset for the rest of the position. That is approach, top, inner, and approach, top, and inner. Those are the ones I need an offset for. So now the same amount of offset for both of them. There you go. Now I have declared that, okay, move to the initial position, then just offset your initial position. I can actually put an offset into the initial position, but for now I'm just going to leave it like that. Yeah. Now I have to calculate this offset, or how much offset do I require. Yeah. The way to calculate that actually is not that difficult. But first of all, this function, you can see that now I have an error in here. And now this error is because the function requires parameters and I'm not putting any parameters in there. So I'm just going to put dx as parameter and dy as parameter separated by a comma. The same thing in here, dx, comma, dy. Now I have another error because I haven't declared what dx and dy mean. Yeah, so to do that, I'm gonna declare some variables. In this case, some variables. We could declare this variable. It's gonna be numerical, and it's gonna be dx, and another variable numerical dy, semicolon. Yeah. Now the only thing that I need to do, because right now the values in here are 0, are gonna be 0, so there's not gonna be any offset. Yeah, I need to put some values into dx and dy. Actually, if I put some values in here, you will see if I run the code, basically it's going to do the same movement but with an offset. Now, in this case, I'm declaring them as variables. Yeah, and now I have to calculate. Well, what should I do? But before that, I am going to use this path home. Remember, we have a home position. Like, okay, before you start whatever you are going to do, go home. Wherever you are, just go home. This is what I'm telling to my robot. And after the while loop, after everything is finished, go home as again. Yeah. So this is the first thing. Go home, then go to the while, do the whole thingy, the whole transferring things from one plate to another, and then go home again after you finished. Okay. So now let's inside the while loop, we're gonna get a function. We're gonna make a function that is called get underscore well, because the well, it's the well, the hole, the vial, the hole of the vial, or the well, we call it wells because it's filled with something. Get well offset, I'm gonna call it like that, and I'm gonna need the number of the well, or the index of the well, the dx, the current dx, and the current dy. Now I have to declare a function that is called getWellOffset. To do that, I'm going to make a process in here, proc, and I'm going to end the process. And in here, I'm going to actually make that function, because these are subroutines. So the function is gonna name getWell offset, and this thing is gonna require a numerical value, which is the well, then a variable, a numerical variable dx, because I'm gonna put the whole variable in there. I'm gonna call it from here. Yeah, I'm gonna modify the variable inside this function. That's why I'm calling it like this. And another variable, numerical variable dy. Yeah, this is just a number. I'm gonna send a number, but in here I'm sending the whole variable so that I can modify it inside the function. I'm gonna declare some variables in here. The variable, a numerical variable called column, a numerical variable called row, and I'm going to start looking for these values. I'm going to start looking for these values according to the number of well, or to the well that I am in. Yeah, to the index of the well. I just want to see if, yeah, it's the same. So for the columns, I can define columns as the well, the index of the well, modulus, and the columns. Yeah, I'm going to define the number of columns in a minute. And for the row, like which row I am in. Yeah, I can do the division. Yeah, integer division. This is an integer division of the columns, well divided by columns. And finally, I can modify the variables dx. Yeah. And I can modify the variable dy. I'm going to explain what each of these things mean in a second. I just want to finish typing. So basically what I'm saying is, okay, what is the index of the well, or of the vial that I am in this case. For example, this is number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 in here, and then this is going to be 12, 13, 14, 15, so on and so forth. Yeah, until it's going to be 21, then 22, 23, 24, 25, I'm sorry, 23, and this is going to be 24, 25, 26, 27, etc., etc. So it's going to be the index of each one of these wells, or of these vials. So this is what this W means, is the index of each one of them. So in total, the number of wells, or the number of vials, is rows times columns. So I have to define a variable here that tells me how many rows or how many columns do I have. So in this case, I can make it here at the top. I can make it like a constant. a numerical constant called columns, and I can define this as 12 columns. Oh, by the way, semicolon, I always forget about that. Constant numerical variable rows. In this case, I'm going to have 8 rows. There you go. So in total, I have 96, 12 times 8. So I can make a comment. To make a comment, I can just use it like this. So it's going to be like a 96 well grid 12 times 8. Yeah. So now I can define also this other variable that I just defined in here, that is xx and sy. Basically, this is the direction or the sense of movement. So basically, it's how much this dx increases or decreases. Yeah. So this is the sense of movement. Because if we remember correctly, let's say this, like for example, I am in the well, I am in a certain well or certain vial, and the index of the vial 1, 2, 3, 4, 5 to 11, or 12, 13, 14 until 23, 24, 25, whatever, until 96, until 95, because it's from 0 to 95. So this is going to be a number from 0 to 95. What I'm going to do here is I'm going to check which column and which row I am at. Yeah, like using this operation here. I verify which column I am in, this column or in this row. Yeah, like which column or which row I am at. And using that, I can just multiply. I can just multiply by a certain pitch. The pitch is the distance from the center of this section to that, or the center from here to here. So that's the pitch. It's always the same. That's why I'm going to put only, that's why I selected as pitch in only one variable, because it's the same distance from here to here, from this center to that center, from the center of A1 to A2, the same as from A to B in the same column. So this is what I'm going to do. That's why I put a pitch in there. So I'm going to put it as a constant. Here I can pull it distance between tubes. I can put it as a constant as well, numerical constant. I can call it pitch, and I can define them as 9 millimeters, because it's 9 millimeters between each one. Millimeters. Okay. So now I have my pitch, and this thing, what I was telling you about, is the sense, like which direction should I move towards to. Like for example, if it's am I gonna move in the positive direction or in the negative direction, positive or negative? Because remember, this is gonna give me the amount of offset, from this position. Like how much offset? Like it's gonna be multiplied by 3, and then by 2. Like for example, 3 in x and 2 in 1 in y, or 2 in y maybe. And this is what is gonna multiply this row and column. But now, to which direction, positive or negative? Yeah, so that's how I define. Yeah, like for example, sense of movement. I can just put it like this. Sense of movement. And in here, I can put it like a constant as well, a numerical constant, Sx. I'm going to put it in positive direction. That's why I put a 1, because it's just positive. And I can just copy paste this. This is in the direction y. Maybe this is going to be negative. Yeah, because I am moving in the negative y direction. You can see the y direction is this way. I'm moving in the negative y direction in both of them. And I'm moving, I am moving in the positive x direction and in the negative y direction. So that's why I put Sx and Sy. Okay, so now that I got my how I get my offset from each one of the points. This is the function to get the offsets. So basically the distances. I can just go and declare, of course, I need to declare what this well means, basically the index of my well. So I can create here a variable, a numerical variable called well. I can create that variable. Now I have it in here. Yeah. And now I can start programming a little bit of the things in here in the inside my while, because again, I need this well to change. Yeah. Also, I need to verify if, if I done all the holes, or if I done all the vials. Yeah, I can just finish. I can just get out of this while loop. There are ways of doing this. One thing will be like, instead of this true, we can just verify if the number of well, if the index of the well is greater than rows and columns. Or I can put as an if. This is just for example, for this example, I'm just going to make it in this way for this example. I can put an if, so that you know that we can put ifs. If the well is greater to rows times columns, so basically if it's more than 96, then immediately exit. So basically get out of the while loop. Else, get me the next offset. And I will end if. I put it like this. I know that this is just an example, so that's why I kept it like this. But of course, I can put it in here in the while loop. That will be way better. But anyway. And finally, I can increase well is equal to the number of the index plus 1. So basically go to the next to the next well, or to the next vial. And as you can see, I have finished with my program. Yeah. I have done everything. I have done the while loop. I have checked the paths. I have done the paths. I have put some offsets into my paths. I have declare. I think this is and process and process and process. Yeah, this is an extra. I don't know why it's got in there, but it's an extra. I added a function basically to verify what's my next, what is the offset, what is my next offset. And using all this, now I can just check the program, or I can apply all. And then after applying all, I have to synchronize this, synchronize to station, synchronize everything to my station. And then I can just go to simulation. And I can start my simulation. It's going to go to the home position, then go and do one, and then the offset of another one. And you can see that it's actually doing the third one, and the third one, the fourth one, and the fourth one, and so on and so forth. So I'm just going to leave it a little bit more so that you can see that it's actually working. I just want to go to the next, because it's quite slow, and I'm not going to wait until I finish the 96 positions. So I'm just going to leave it like that. And maybe, as you can see now, is the final. Well, the first column just finished. The first column starts with the next one, and so on and so forth. Okay, so that's it for this tutorial. in the next tutorial, we're going to learn how to make some inputs, to have some inputs and some outputs of our controller. Yeah, we're going to use exactly this. Actually, we're going to use this example. So if you want it, I will share this tutorial with you. Yeah, and everything that goes inside of this tutorial with you as well. Just look in the GitHub page. Yeah, thank you so much, and see you in the next tutorial.